So typically, for any right angle triangle, you only ever need two sides. Because you've got those three ratios, the three ratios will involve every possible combination of two sides. So, in other words, if I give you any two sides of that triangle, you'll be able to pick those two sides and immediately be able to pick which one you want to use. So, for example, in the previous one I gave you these two, so let's try a different scenario. So let's say I gave you this one, these two this time. Let's say I gave you this one. So let's say this was 200 feet. Let's do this one in feet. Doesn't really matter what the units are, but in feet, get familiar with it. So we'll say that's 200 feet, and let's say that this side here was 4 times it, so let's say it was 800 feet. And we just looked at it and said, okay, I want to find this angle. How would you deduce which of the three formulas do I want to use? So obviously you pick the one that has the two knowns. So you pick the one that has the two knowns. So you've got opposite, you've got adjacent, so you go straight to the one that you want. So you write that formula down. So okay. That way you don't waste time looking at the other formulas. You pick the one you want first, and then you just write the formula down. Again, I'll get you to draw an accurate diagram on that one. So it's up to you to pick the scale. What scale? Now you don't want the diagram too small. So if you pick say 100 to 1, that might be a bit small, because if you pick 100 to 1, that'd only be 2 centimetres, which would be quite small. So I'd suggest maybe 25 to 1, or maybe 50 to 1. 50 to 1 would be a good scale. Just something that fits neatly on the page. I mean, it'll be pretty obvious. If you get the wrong scale, it'll be too big or too small. So, but I would say for that, maybe 50 to 1 scale, meaning 50 feet equals 1 centimetre. Go. So you'll draw it over here. A matching diagram, if you like. The scale diagram will look something like that. And it'll be 4 centimetres. And it'll be 15. And that should easily fit on the page. So I think that's something that really is ignored at school, the ability to draw your own diagrams, because everything these days tends to be presented to you or given on a computer or something. They don't get you to initiate the thought process of having to draw your own diagrams. And I think that's quite an important thing, because it makes that connection in your brain of, okay, I'm connecting the actual real life situation with my diagram, and the diagram, at least angle-wise, is representing exactly the correct angles. So the angles that I'm going to get here should be precisely the same angles that I'm going to get over here. It's not an approximation, it's actually spot on. So it's a neat way of checking your answers. I think my diagram's a little bit off, so let's try and fix my diagram up. Try and make it a bit more accurate. So it'll be 4 to 1, so it should be more like that. So again, I'm looking at that going, well, 16 centimetres. So it should be about 15 degrees roughly. And Chris, you know the 1 in 60 rule, so you'd know how to check that as well using the 1 in 60 rule. So you would simply go 4 over 16 is a quarter. Quarter of 60 is 15. There's your angle, 15 degrees. Give or take a few decimals. So the 1 in 60 rule will also get you a rough estimate, but obviously the diagram is more accurate. Yeah. So let's say we wanted to calculate that angle, so we would go, I'm going to use the actual numbers. Now let's do it both ways. Now let's just do it both ways to convince ourselves that it works in both contexts. So if I was using this diagram, I was using the actual numbers, it would be 200 over 800. If I was using my scale diagram, it would be 4 over 16, but obviously it's the same ratio, so you can see it's going to give you the same result. So I think it's an important thing to convince yourself mentally that you don't have to use the centimetres. You can go straight here and use the actual numbers that are presented in the question. So my tendency would be to use this one, but there's nothing wrong with doing that. I mean, you scale it as long as you scale it correctly. It's just that these numbers are probably less prone to error because you use the scaled numbers. I mean, if you made a mistake with the scale or something then. So it should be about 15 degrees. So again, we're looking for an angle here. So we're undoing the tan function, so if you feel like the inverse function of the tan function. I better write that properly so you can see what I'm doing. So it's 25% or 0.25. So really it's saying, the equation saying it's the angle whose tan is 0.25, which should be about 15 degrees. Right. Practice our rounding. 14.04 to round to 2 decimals. Do you want to see how I'm getting that? So notice there's a 6, it's 0.036, so if you're rounding to 2 decimals, it would be 14.04. So the rule there is 5 or above, you go up. Obviously you get the same result if you use the 4 over 16. We don't need that, but you will get the same result. And then again, just for the practice, that third angle in there, let's say we wanted the other angle, the alpha, would just be 90 minus 14.84, which would also be the north. Again, if I'm on a map, and if that was north, it would also be this angle here. So that angle there would be the same as the opposite angles are equal. So Z rule again. So that would be like 76 or 75. And if I was thinking in terms of a map, that would be 0.75 going that way. And notice we didn't need to calculate the longest side yet. We didn't even need to calculate that longest side, although we probably should just for the practice. So we'll get you guys to do that. Calculate the hypotenuse length using the Pythagoras formula. So we'll call that side A. So again, I normally use those labels A, B, C clockwise, which makes it easy. You don't think always make A the longer side, and then just go clockwise A, B, C, just saves confusion. You do it the same way every time. Again, it will be a square root function. Again, you can do the scaled one, or you can just use the original numbers. You might just use the original numbers, that's quicker. You can put all that in your calculator in one go. Show you how to do that. Should look. These calculators are nice, so it should look exactly the same. Yeah, we can read that. Yeah, so it should look exactly the same on your calculator as it looks on my page, on your page. So literally, you get the square root, and then you just type everything in. It does the whole thing for you. Let's check that we have the right answer. So we want to be able to check that. So let's convert that to your scale diagram. So convert that number, because you want to check it on your diagram. So convert that back to centimetres now. Does everyone know how to do that? What was the scale you used? 50 foot was 1 centimetre. So if you divide by 50, that'll convert it back to centimetres. So you should always have that in your mind, that you can, if it doesn't look right, go to your diagram, you check it, put the rule on there, actually physically measure it, just check that it is 16.5. So it's easy to make a mistake it's easy to make a mistake here with your maths and you're punching a number in incorrectly, decimals, whatever. It's very easy to make mistakes. But you'll find that diagram, you rarely make a mistake with the diagram. The diagram is often the backup, not the other way around. So it's always good to check your answer. So stick your protractor on there again. I'll borrow your protractor again just to show you home viewers there. So that'll do that. So stick your protractor on there, on the point of the triangle, and just check that that is in fact 20, or what is it, 14 degrees, sorry, 14 degrees, and mine looks like pretty much spot on actually. So there you go. That's good for that page.
Page C, wouldn't that 824.6 be feet?
Oh yeah, sorry, I'm in feet, yeah, sorry, thank you. Thank you for that. What is it? Yeah. So that's all feet, so everything's feet. Obviously all the same units, so triangles work in any unit, so as long as you're all the same units, it wouldn't matter if you did it in inches, if you do it in millimetres, if you do it in yards, it really wouldn't matter. Provided they're all the same units, it'll all work. And as long as you keep the scale, as long as you keep using that same scale, the angles should work. So if you stick the protractor on here and measure that one, that should be 76 degrees.